Have you ever wondered what truly happens in your brain when you get really lost in a good book? Or maybe when a line of poetry just hits you differently, gives you that sort of unexpected shiver? Well, today we're going to dive deep into exactly that. We're exploring the invisible pathways in our minds that make us fall in love with words. Our focus today is on this really groundbreaking field called neurocomputational poetics, and specifically an incredible architectural blueprint for a system designed to analyze literary language. Our mission here in this deep dive is to understand how this system takes something really subjective, that often mysterious experience of reading poetry, and transforms it into something measurable, quantifiable, and well, truly insightful. Think of it maybe as a shortcut, a way to understand that intricate dance between language, art, and the human mind. We're moving from traditional literary analysis to these predictive computational models. So yeah, let's unpack this.
It's fascinating, actually, seeing how literary analysis has evolved, because for centuries it was mostly, subjective. It relied on close reading, individual interpretation, and those methods gave us really profound insights, absolutely. But they often lacked a way to empirically test or replicate those insights across different readers.
Right, yeah. It felt powerful, but like you said, different brilliant minds could have equally valid, but still totally different takes. So if you wanted something more consistent, maybe more provable, what was the first big step towards bringing more empirical rigor in?
Well, the initial movement was called stylistics. That approach started applying linguistic rigor to texts, focusing really meticulously on objective language features, trying to understand how they created aesthetic effects. But the truly fundamental shift, what's often called the cognitive turn, went even further. It moved the focus away from the text just sitting there as a static object, the dynamic interaction between the text and the reader's mind.
Oh, okay. So it's not just about what's on the page, but what happens in your head when you read it. That sounds like a pretty profound shift.
It absolutely is. And out of this cognitive turn came cognitive poetics. This school of thought basically suggests that literature isn't some, totally esoteric thing with its own secret rules. It's actually more like a specialized application of our general human cognitive abilities, how we perceive things, how we remember, how we pay attention. So it applies principles from cognitive science, psychology, linguistics, neuroscience to interpret how texts are made and how we perceive them, moving beyond just vague ideas like a poem having resonance.
That makes a lot of sense, actually. Can you give us a concrete example? How does this cognitive approach work in practice?
Sure. A really powerful example is conceptual metaphor theory, which Lakoff pioneered. This theory isn't just about, spotting metaphors. It's about understanding them as fundamental reflections of how we structure thought. They're not just fancy decorations. They actually shape how we think and feel. So by analyzing how a text uses these deep conceptual metaphors, we can start to explain pretty precisely how a writer guides your emotional response. Big picture. It's about reconnecting scholarship with the sort of natural reader's everyday experience, blending that artistic sensibility with scientific rationalism.
Wow, okay. That's a huge leap. So if we want to build a system that captures this, what's the next piece? How do we get from theory to testable, predictive models of reading?
Right. That's exactly where the Neurocognitive Poetics Model, or NCPM, comes in. This is the core theoretical framework, the architectural blueprint for the whole system we're talking about. Its central idea, it's actually inspired by brain models for how we read words aloud. It suggests that literary reading, complex as it is, also works through two distinct but interacting pathways in the brain. And these pathways get activated by different features in the text, leading to really different experiences for you, the reader.
Okay, two pathways. That sounds like a really critical distinction. Can you unpack those a bit? What's each one do? How are they different?
Sure. The first is what we call the fast automatic immersive route. This one gets triggered by background features, things that are familiar, expected, fluent. Think common words, normal sentence structures, recognizable themes, standard story arcs. Your brain processes these mostly implicitly, kind of on autopilot, using well-worn cognitive shortcuts or schemas. And the result for you, immersion. You get absorbed in the content, the story, the characters, the world. This leads to what are sometimes called fiction feelings: sympathy, suspense, maybe vicarious fear for a character. Neurally, this seems to rely mainly on those well-practiced language networks, often in the left hemisphere.
Okay, so that's when you're just totally lost in the story, feeling it all. Makes sense. What about the other route?
The second one is the slow, explicit aesthetic route. This gets triggered by what we call foregrounded features. These are the artistic techniques that make language feel strange or novel. Things like unusual metaphors, really complex or maybe grammatically weird sentences, ambiguity, striking sound patterns, alliteration, rhyme, meter. Processing these takes conscious effort. It's explicit, controlled. It can feel kind of disfluent, actually. Requires more cognitive resources, more attention. It actually tends to disrupt that easy immersion from the first route. And the experience isn't about getting lost in the content, but more about a conscious appreciation of the text as a crafted object. This leads to aesthetic feelings or artifact emotions like feeling awe at a beautiful line or surprise at clever wordplay, a real appreciation of the writer's skill. And this seems to engage a wider network of brain regions, maybe right hemisphere areas involved in novelty, the prefrontal cortex for control, perhaps even subcortical reward circuits.
Huh. That dual route idea sounds like it could really help with that old tension in literary studies, right? The whole content versus form debate.
Yes, exactly. It provides a powerful way to model that. For a long time, there was this sort of split between analyzing what a text is about versus how it's written. This framework gives us a systematic way to look at that dynamic interplay. The immersive route maps pretty neatly onto our engagement with content, while the aesthetic route relates more to our appreciation of form. It lets us see how both are happening, often at the same time.
Can you give a quick example? I think the blueprint mentioned a line from Poe.
Yeah, the line from Annabelle Lee. Chilling and killing my Annabelle Lee. So on one level, it's reporting something incredibly sad, her death. That's content, right? Engages the immersive route. You feel the sadness. But at the same time, that strong internal rhyme and the alliteration, chilling, killing it, has this almost like naive sing-song quality, despite the darkness. That's the form. That striking sound pattern engages the aesthetic route. The NCPM helps us see how you can have both that sadness and that sort of odd aesthetic effect simultaneously.
That's a fantastic illustration. Okay, so how does the system measure this stuff? Let's get into Module 1, the cognitive load model. You said traditional readability scores, like Flesch-Kincaid, they just don't cut it for poetry.
No, not really. Those metrics are pretty superficial for this task. They look at things like average sentence length, word length, fine for maybe general prose, but they completely miss what makes poetry demanding. They don't account for figurative language, metaphors, similes, or unusual syntax, inversions, ambiguity. They'd often mark really complex poems as easy, which, well, anyone who reads poetry knows isn't right.
Yeah, definitely not. So this module isn't about readability then, it's about cognitive load. What does that really mean for understanding poetry?
Exactly. It reframes the problem as cognitive load, the amount of mental effort a piece of text demands from the reader. It's grounded in ideas like Baddeley's working memory model, which has limited capacity. Poetic language often pushes that capacity. It also draws on computational models of attention, like how eye tracking shows fixation time relates to processing difficulty. Basically, high cognitive load measures how much a text deviates from everyday easy processing. It quantifies that feeling of defamiliarization or making strange that artists use. And crucially, it's thought to be a key trigger. High load might be what signals your brain to shift focus from just understanding the content to appreciating the artistry, engaging that aesthetic route. It's a primary input for simulating feelings like surprise or confusion later on.
Okay, so high cognitive load is like a signal. Pay attention, something interesting is happening with the language itself. How does the system actually calculate this score?
It's a composite score, a weighted index from 4 different NLP submodules, each looking at a different kind of complexity. First, there's lexical and morphological complexity. This looks at the words themselves. Metrics like vocabulary diversity are there lots of different words. Lexical density, how many content words versus function words. Word rarity, are these common or unusual words. And morphological complexity, do words have lots of prefixes or suffixes. Tools like Spacey help here.
Okay, so the words themselves, what about how they're strung together? Sentence structure.
Right, that's the second part, syntactic complexity. This assesses how hard the grammar and sentence structure are to process. It measures things like average sentence or clause length, how deeply nested the grammatical structures are, think complex sentences with lots of clauses. It uses things called dependency tree depth, Yingvi scores, Fraser scores. Basically ways to quantify the memory load needed to parse the sentence. Again, tools like Spacey are used to get those parse trees.
Got it. And then the meaning part, especially those tricky metaphors you mentioned.
Yeah. Semantic and figurative complexity. This focuses on the effort needed for non-literal meaning, especially metaphor density and novelty. A really novel metaphor, one you haven't seen before, forces your brain to do more work to map concepts. The system uses state-of-the-art techniques here, like the metaphor identification procedure, or MIP. It looks for incongruity between literal and contextual meaning. It might use models like Roberta to see if a word fits weirdly in context, or vector embeddings to measure the semantic distance of the metaphor.
Okay, makes sense. And the last one, what if a poet just breaks the rules entirely, like unusual grammar or word order?
That's covered by structural and grammatical novelty. This directly measures deviation from standard language patterns, a key way poets create that foregrounding. It looks for statistically rare grammatical structures or word combinations, collocations. And interestingly, it measures what a standard grammatical error correction, or GEC model, would flag as an error. But here's the key insight. What a GEC model sees as a mistake in normal prose, this poetics analyzer interprets as a deliberate artistic choice that demands more cognitive effort from the reader. It might use transformer models like T5, fine-tuned for this.
Wow, turning an error into a measure of art. That's clever. Okay, so that's cognitive load. But poetry is so much about emotion. How does the system handle that? That brings us to module 2, right? Simulating affective trajectories.
Exactly. Standard sentiment analysis, just positive or negative, is way too simple for poetry. A poem can be sad and beautiful, right?
Totally.
So this module uses a multi-label emotion classification approach.
Multi-label, like it can have several emotional tags at once.
Precisely. Like tagging a photo, not just happy, but happy, nostalgic, maybe bittersweet. It does that for lines of poetry. It uses a psychologically grounded set of emotions, maybe Ackman's Basic Six: joy, sadness, anger, fear, disgust, surprise. But importantly, it adds aesthetic categories too. Awe, beauty, confusion, humor, things like that.
And what about the sound, the rhythm and meter? Does that factor into the emotion?
Absolutely crucial. Poetry sound, its prosody, rhythm, meter, alliteration, rhyme, carries a lot of effective weight. Even reading silently, you sort of mentally hear it. The system models these implicit prosodic qualities. It calculates scores for these sound features, and those scores become inputs for the emotion simulation. The musicality directly influences the predictive feeling.
Okay, this is where it gets really interesting, I heard. Using large language models, LLMs, not just as classifiers, but as affective simulators. How on earth does that work?
Yeah, this is a core innovation. Instead of just asking an LLM what emotions are here, we use sophisticated prompt engineering. We basically guide the LLM, could be GPT-4, Llama 3, something similar to adopt a specific persona, like a highly sensitive and articulate literary reader. And we force it, through the prompt structure, to give a line-by-line first-person analysis. But critically, it has to output this analysis into two distinct categories.
Let me guess, mirroring the NCPM, the immersive and the aesthetic roots.
You got it. Category 1 is immersion and narrative feelings. Here, the LLM describes responses to the content, like, I feel sympathy for the character here, or this image evokes a sense of loss. Category 2 is aesthetic and artifact feelings. This captures responses to the language itself. I'm struck by the surprising beauty of this metaphor, or the choppy rhythm here feels quite jarring and anxious. So the LLM becomes this transparent data generator. It creates a structured text record that simulates a reading process, capturing both kinds of feelings.
That's fascinating, like getting a transcript of a simulated reader's emotional journey. But how do you get numbers out of that text?
Good question. That's the next step. A second NLP pipeline processes the LLM's free text output. A multi-label emotion classifier, maybe a fine-tuned BERT model, reads the LLM's descriptions and assigns quantitative emotion scores, like intensity scores for sadness, awe, confusion, etc. Then a rule-based system sorts these scored emotions into either the immersion track or the aesthetic track based on which category the LLM generated them under. This creates what we call an affective trajectory, basically, a time series data set showing how different emotion intensities change line by line along both the immersive and aesthetic pathways.
Wow, so you can actually graph the emotional ups and downs of reading the poem on two different levels? That allows testing specific hypotheses, I guess?
Exactly. It lets us test ideas from neurocognitive poetics. For example, does high cognitive load reliably predict stronger activation of primary emotions like surprise or awe on that aesthetic track? This hybrid approach lets us explore those connections.
Okay, that's incredibly sophisticated for emotion. But reading isn't just about complexity and feelings in the moment. We bring our whole history, our knowledge to a text. How does the system account for memory? That's module 3, right?
Yes, module 3, integrating semantic and episodic memory. You're absolutely right. Readers bring a lifetime of knowledge. This module models that by distinguishing between two crucial types of memory, much like our own minds seem to do. First, there's the semantic network. Think of this as modeling your general world knowledge, facts, concepts, relationships that aren't tied to a specific time or place. It's built on a foundation of distributional semantics, using pre-trained word embeddings, things like glove word to vec, or contextual ones from transformers like bird. Words are represented as vectors in a high-dimensional space, where similar words like boat and ship are close together. Cosine similarity measures that closeness.
Okay, so it captures general relatedness. But what about more precise links, like knowing a robin is a type of bird?
Right, the embeddings are good for broad associations, but we enhance them. We augment this distributional base with a structured, symbolic knowledge graph like WordNet, or maybe knowledge extracted from Wikipedia. This adds explicit hierarchical relationships like isolinks, has property links. It combines that broad statistical knowledge with more precise logical structure. It's a richer model of world knowledge.
Got it.
And the second type of memory.
Episodic.
Yes, the episodic buffer. This is more like a temporary workspace, inspired by extensions to Baddeley's working memory model. It's dynamic. It processes the specific, unfolding context of the current poem. It builds up an integrated representation of the text world as you read. Technically, this might be implemented using something like a recurrent neural network, LSTM, or the self-attention mechanism in transformers. These maintain a memory, or hidden state, that represents the accumulated context. This is crucial for things like resolving ambiguity, understanding that bank means a riverbank in one context and a financial institution in another, or tracking who he refers to. It models how a word's meaning gets shaped by everything that came before in that specific poem, like understanding night differently in an elegy versus a lullaby.
So these two memory systems, semantic and episodic, they work together during interpretation.
Constantly. They're in continuous interaction. Say moduli flags a metaphor like, my love is a fever. The semantic network retrieves general properties of the source domain, fever, illness, heat, lack of control, maybe delirium. Then the episodic buffer takes those properties and maps them onto the target, love, but specifically within the ongoing context of the poem. The semantic distance between love and fever in the network can even give a clue about the metaphor's novelty or conceptual leap.
And this relates back to cognitive load too, doesn't it, with schemas?
Exactly. The semantic network helps define schemas, those frameworks of expected knowledge. A poem can play with these. It can conform to a schema, making things feel familiar, or it can violate a schema for artistic effect, like the church bells wept. That violates the typical schema for church bells. The system can calculate a schema violation score, which contributes to cognitive load and signals foregrounding.
It sounds like it could even model priming effects, where seeing one word makes you process a related word faster.
Yes, this dual memory architecture is well suited for that. When the system encounters ocean, that node gets activated in the semantic network. Activation spreads to related nodes like wave, tide, ship. If the word wave appears shortly after, it requires less computational effort to process because it's already partially activated or primed. The model registers this as a negative contribution to cognitive load context, actually made processing easier.
Okay, this is generating a massive amount of complex data load scores, emotional trajectories, memory activations. How does a human researcher actually make sense of all this? That must be Module 4, the visualization dashboard, the analyst's cockpit.
That's exactly its role. Module 4 is the primary user interface. It's designed to transform all this complex data into visual insights that are actionable for a human researcher. It's not just a static report. It's conceived as a dynamic hermeneutic tool. It's meant to facilitate a dialogue between the computational analysis and the human scholar's interpretation.
What's the thinking behind building such an interface? Any key principles?
Well, it's built using modern web technologies. Think a single-page application, maybe using React for the structure and components, and D3.js for rendering those really complex custom data visualizations. D3 is great for binding data directly to graphical elements, but a core principle, absolutely central, is accessibility. It's designed following WCAG 2.1 AA standards. That means things like text summaries for visualizations, high contrast and colorblind-friendly color palettes, full keyboard navigability, proper use of ARIA roles for screen readers. The goal is to make these powerful insights accessible to everyone.
That's really important. Okay, so what would I actually see in this cockpit? What are the main visual parts?
There's several core components. First, the poem fingerprint view. This is the main overview. You see the poem's text, and alongside it, synchronized line-by-line graphs, maybe stacked area charts or heat maps. These plots would show things like the total cognitive load, but also broken down by type: lexical, syntactic, figurative, structural. And critically, the effective trajectories, separate graphs showing the intensity of immersive and aesthetic emotions unfolding over the poem.
Wow, so you get that whole landscape at a glance. What if you want to zoom in on something specific, a tricky line or word?
That's what the Syntactic and Semantic Explorer is for. You click a word or line in the main view, and this panel updates. It might show you the dependency parse tree for that sentence, a visual map of its grammatical structure, and maybe a local semantic network, a force-directed graph showing related concepts pulled from the memory module for that specific word in context. And then there's the NCPM processing route flowchart. This offers a higher level view, dynamically mapping segments of the poem, maybe stanzas or lines, to either the fast immersive route or the slow aesthetic route based on the outputs from the cognitive load and effective simulation modules. It summarizes the predicted reading process.
And it all links together interactively. That sounds key for actually using it.
Absolutely. Interactivity is crucial. All components are linked and responsive. Clicking a peek in the cognitive load graph will highlight the corresponding line in the text, update the Syntactic Explorer for that line, and focus the NCPM flowchart on how that segment was likely processed. We call this cross-filtering or highlighting. You can hover over elements to get tooltips with precise numerical values or definitions. And importantly, there's an annotation interface.
Ah, which connects to the next module, the refinement loop.
Exactly. It serves as the front end for Module V, allowing the user to provide feedback and corrections directly within the visualization environment.
So this whole dashboard design really encourages moving between the big picture, the distant reading view of patterns, and the tiny details, the close reading view, augmenting what a scholar already does, but with new kinds of evidence.
Precisely. It embodies computational hermeneutics, using computational tools within an interpretive cycle. It models the process of interpretation, not just a single end result.
Okay, speaking of refinement, that brings us nicely to the last piece, Module V, the refinement loop, an active learning ecosystem. I guess the challenge is that poetry is always changing, always innovating. A static system would struggle, right?
That's a fundamental challenge. Poetry thrives on breaking rules, on ambiguity, on fresh expression. A model trained only on existing text will inevitably stumble when faced with truly novel poetic language. So Module V uses active learning, or AL. It's a smarter, more efficient way to learn compared to just passively training on random data. AL works by having the system interactively query a human expert, the oracle, but only for labels on the data points where the system itself is most uncertain or which it identifies as most informative for improving its models. This drastically reduces the amount of human labeling needed.
Right. So the system says, I'm really not sure about this specific metaphor, or my internal models disagree on this syntactic structure, and asks the expert for clarification. How does that loop work?
It's a continuous cycle managed by a controller. Step 1. The system analyzes a new poem using all the modules we've discussed. Step 2. The AL controller identifies uncertainty. It uses a query strategy, maybe uncertainty sampling, which picks points where the model has low confidence, or query by committee, where it picks points that different internal models disagree on the most. Step 3. It queries the oracle. The system presents these uncertain points to the human expert, probably through that annotation interface in the dashboard we just talked about. The questions could be quite specific. Is sullen an adjective or adverb here? Or maybe, does this line primarily evoke awe or confusion in a human reader?
And the expert provides the answer.
Right. Step 4. Receive feedback. The expert gives the definitive label or correction. Step 5. Retrain or fine-tune. This high-value, targeted, newly labeled data point is added to a special training set. And the relevant model, for example, the metaphor detector, the emotion classifier, is incrementally updated or fine-tuned. Then the cycle repeats. The system gets progressively better, constantly refining itself with expert guidance precisely where it's needed most.
And you mentioned it doesn't just rely on uncertainty, it combines that with novelty detection.
Yes, that's a key refinement for poetics.
Yeah.
Standard AL might just focus on uncertainty, but here, the query strategy is often augmented with novelty detection, drawing potentially from Module 1. So the system preferentially selects instances for querying that are both uncertain and novel linguistically, like a rare syntactic structure or a highly original metaphor. This ensures the expert's time isn't wasted on common ambiguities, but is focused on the poetically interesting, innovative, and challenging aspects of the text where human judgment is most valuable.
So the system uses its own computed uncertainty and novelty scores as signals to know exactly when and where to ask for human help. That sounds like a really powerful way to handle the sheer creativity of poetry.
It is. It creates an ecosystem where the machine learning models and human expertise continuously learn from each other. It addresses the inherent brittleness of purely automated systems when facing genuine artistic innovation.
Okay, let's try and bring it all together then. We've got these 5 modules: cognitive load, effective simulation, memory, visualization, and active learning. How do they interconnect to create this holistic model of reading?
They're deeply intertwined. It starts with the poem input. Module 1, cognitive load, and Module 3, memory, do the initial analysis, calculating complexity, activating semantic networks, generating that foregrounding score. These outputs feed into Module 2, effective simulation. The cognitive load scores, for instance, help determine whether the aesthetic pathway gets strongly activated in the LLM simulation, leading to predictions of aesthetic emotions. The memory module provides context for interpreting metaphors and schemas, influencing both load and effect. All these layers of analysis, load, effect, memory interactions are then sent to Module 4, the interactive visualization dashboard, for the human researcher to explore and interpret. And overseeing everything is Module 5, the refinement loop, which continuously monitors model uncertainty and novelty, queries the analyst via the dashboard when needed, and uses that feedback to fine-tune the underlying models in Modules 4, 2, and 3. It's a constant feedback loop.
What are the bigger implications of a system like this for, say, the digital humanities?
I think it's a significant step forward. Much of distant reading has focused on finding patterns across large collections of texts. This system enables what we might call modeled reading, a much richer process-based simulation of how an individual reader likely engages cognitively and emotionally with a single text. It tries to model the dynamics of reading itself. It also acts as a concrete bridge between the so-called two cultures, the sciences and the humanities, using methods from one to explore the core questions of the other. It's designed to augment scholars, not replace them, to provide new forms of evidence, new perspectives, new questions. It embodies that idea of computational hermeneutics, using a scientific iterative cycle to explore meaning.
It sounds incredibly promising, but what are the limitations and where does this kind of research go next?
Well, there are definitely limitations. Any model is only as good as the data it's trained on, so biases in the training data can be an issue. And as we touched on, the current model simulates a kind of generic reader. It doesn't yet fully capture individual differences. Your specific prior knowledge, your personality, your cultural background all shape how you read. And of course, there's the deeper philosophical question: can an AI truly experience an emotion, or is it just simulating the patterns associated with it? That's a whole other conversation.
True. So, future direction.
Lots of exciting avenues. Multimodal integration is a big one, combining these computational models with real-time biometric data from actual human readers. Think eye tracking, EEG brainwaves, maybe even fMRI scans. That could help validate and refine the models enormously. Personalization is another key direction. Can we build models that adapt to a specific user's knowledge base, their typical effective responses, maybe even their level of literary expertise over time, creating truly tailored analytical tools? And then there's expansion, applying these principles beyond poetry to other forms, like prose fiction, or adapting the system for different languages to enable comparative literary studies on a whole new level.
So, wrapping up, what does this all really mean? For us, for anyone listening who loves literature, I think it means we're getting closer, closer to truly understanding those invisible pathways in our minds, the ones that make us fall hard for a certain phrase or get completely swept away by a story. It feels like it's moving beyond just asking what a poem means to really exploring how it creates that meaning right inside our own heads, our own cognitive systems. And like you said, this system isn't about replacing the human reader, not at all. It's more like a powerful new lens, a microscope maybe, allowing us to see the incredibly intricate mechanisms behind some of our deepest, most profound artistic experiences. Imagine, just for a second, applying something like this to your own reading habits. What if you could see a map of what truly captivates your specific mind in a text? What kinds of insights do you think that would reveal about your own unique way of experiencing literature? Something to think about.